Welcome to homework.
Um, so, once again, welcome to a new problem. And this time we do have headlights. We're still dealing with lights. And so anytime you're dealing with lights, you're going to have a couple of formulas. You'll have wavelengths to talk about. And also you could have other issues like reflection or diffraction. So in this particular problem, we do have two headlights. So think of it like a car that's driving, and we have two headlights right in front of you. And then assume that your eye is at a certain position from the headlights. So your eye is able to see both of them, and it just so happens that the two headlights are 1.4 meters apart. And the problem has two requirements. The first one is we want to find the angular separation. We want to find the angular separation. That's this angle right here, theta r. And then the second thing about the problem is we want to find out the maximum distance, and by maximum distance we mean that the L. So we want to find the maximum distance that the eye can resolve them. That the eye can resolve these two headlights. So this is a headlight. The second one is also a headlight. So that's part of the problem. Other pieces of information that were given is that the diameter of the eye is in millimeters, 5.0. And then also this wavelength right here, lambda, is given as 550 Newton meter. By now you've noticed it's a common number. So that's your typical wavelength of light. And there are certain assumptions that are made in this particular problem. One of them being that we can apply Rayleigh's criterion in this problem because diffraction effects limit the resolution. Okay, they limit the resolution, and remember, diffraction is when light is spreading out. So you want to think of it that way. So those are the pieces of information that were given. It's helpful to remember that the angular separation is given by this formula 1.22 lambda d. Angular separation obviously being this one right here. And then this is where the observation is happening. Oh, that's where the observer is, and these are the headlights, and the light is traveling towards the observer. And so angular separation is 1.22 lambda over d. That's the angular separation, and the maximum distance obviously is given by an alternate formula L, which is d over d, all of 1.22 lambda. Lambda is the wavelength. Small d happens to be the diameter of the pupil, and then capital D is the distance between the two headlights. So those are the pieces of information that were obviously given in the problem. So we want to compute these two, the angular separation and the maximum distance. So delta R equals to 1.22 times lambda, which is 550 Newton meter. We want to change that to meters. So 10 to the 9 Newton meter is 1 meter. And then we want to divide that by the distance between the pupil. So change that into meters. 1 meter is 1,000 millimeters. And so we end up finding that theta r, which is the angular separation, is equivalent to 1.34 times 10 to the negative 4 radians. That's the angular separation right there. The second part of the problem, we're going to go ahead and look back. The requirement was to find the maximum distance, L, between the that the eye can resolve. So we want to find the maximum distance that the eye can resolve, L. So we go back and use the appropriate formula, this one. And so L is equivalent to capital D, small d, and those have meanings. Remember, capital D is the separation between the two headlights at 1.4 meters, and then small d happens to be the diameter of the pupil. We're going to change that from millimeters to meters, assuming that 1 meter is 1,000 millimeters, and then we have 1.22 times lambda. Lambda is also given as 550 Newton meter. Have to transform that into meters, 1 meter being 10 to the 9 nanometers. So our L becomes 10.43 kilometers, or you can say, if you want it to be in meters, it's going to be 1.043 times 10 to the 4 meters, if you want to have it in meters, but having it in kilometers is still fine. So hope you enjoyed the problem. Again, we had two requirements, the first one being the angular separation. We used the theta r and L formulas, angular separation and maximum distance, and plugged in using unit conversions, and we simplified the problem. So hope you enjoy the problem. Feel free to send any questions and comments, and have a wonderful day. Okay, thanks. Bye.